Okay, today's topic, as I mentioned, is automation of cabinet machining. Based on the number of attendees, seems like there's a lot of interest in this. So what the topics we're going to be covering are cabinet panels layout. Don's going to be starting out with taking a cabinet, a three-dimensional model of a cabinet, then using our panel layout tool to lay these panels out on a flat plane. Then once he's done, he's going to go into nesting and actually nest them on sheets so you can actually machine these panels out. And then also he's going to be talking about defining and saving knowledge bases to actually do the machining, and also at the same time automating it as much as possible. So he's going to be talking, and then using the next step would be actually using these knowledge bases in automation. And this would be one level of automation, if you will. And then once all of this has been worked out, then we can actually step up the automation by writing some RhinoCAM scripts and using these tools that we have already developed and using them on the RhinoCAM scripts to make it a single button poke automation. So that's the topic. So Don, if you want to get started.
Okay. Hello, everyone. Thanks for joining us today. What you see on your screen right here is what we're going to be covering in the demo portion of the webinar. So let's take a moment to absorb what we're showing on this screen. You see that we got 3 stages or steps, one being the model of the cabinet itself, the assembly model. The second being the knowledge base that we're going to create in order to automate machining. And on number 3, we've got the nesting and the automation of the toolpaths from the knowledge base. So we're going to be, I will mention, which step we're in whenever we go through it. And try to make it as clear as possible. And if you got any questions, do feel free to add them in the questions panel in the GoToWebinar dialogue. Okay, so on the left here, we got the 3D model of the panel of the cabinet, and what we're using is as you can see, a speaker box. We've got flat panels to make the box, and we got some components inside the box. So we've got some cutouts for here up the top, and we got some cutouts for the components, etc. So in the middle here is 2. You'll see that we have 2 CAM operations in our knowledge base. And then over here on the right, basically just after the nest is complete, we're going to apply the knowledge base and regenerate the operations to automatically do the machining. Okay, so that's basically what we're going to cover. If you got any questions, add it in the questions panel. So I'm going to go right into Rhino, and this is RhinoCAM 2024 on Rhino 8. And as you can see here, we've got the cabinet panel. Let's just change something here. We've got the cabinet panel with our components inside. And as you can see, we're going to be doing some layering. So over here on the right, we've got 1 layer for the components, as you can see, and I'm just going to turn the components off. One thing to mention here is when you do this whole process, it doesn't have to be a cabinet. I mean, it's just, you can lay out anything and actually nest it and machine it using these same procedures. But we're showing it in a cabinet, which is the most used application for this. So I hid the layer for components, okay, and I've got the assembly. Now, one thing to note about the assembly, it needs to be separate poly surfaces for each panel. As you can see, I'm selecting the panels. It can't be just surfaces, not connected surfaces. They have to be merged surfaces into a poly surface or a solid per se. Okay, so we got these assembled, each of the flat panels. And first thing we're going to do is we're going to lay these panels. We're on step 1 in our slide. So we're going to lay these panels out flat using our layout panel utility. And then we're actually going to skip to step 3 and do the nesting part. And then we're going to come back and do the knowledge base. Okay, so we've got RhinoCAM 2024 for Rhino 8 loaded. We got the milling module loaded. The utility to lay these out on a flat plane is right here under the utilities in the RhinoCAM 2024 machining browser on the program tab. You'll see that you see the utilities icon. Just drop that down, and it's got an option called flat panel layout. So we're going to use that. And to lay these out flat, we're going to use one dialog, and I'm going to go over just a few of the options that we're going to be using in this particular application. We're going to flatten out all the visible panels that we have on the screen. We're going to align them or flatten them out along the x-axis, so they'll be aligned on the XY plane in the x-axis. Okay, and spacing, we'll just make it 1 inch so we can see them good. So that's the spacing edge to edge. If you look at the little icon here, you'll see what we're talking about here. And for the geometry that we're laying out, we're going to create 3D geometry only. So each panel will be a solid model as it is laid out flat on the XY plane. And these other options we're not going to really change. We're going to create geometry in the current layer, okay, which is layer 01 here. And we're going to hide the original geometry. And that's about it here. Let's go ahead and run it. Okay, so what you see here is we got it laid out on the XY plane. Okay, and I'm going to go to the top view. So here's our flat panels. And we're going to grab those and we're just going to drag them down outside of the positive XY quadrant. This is the area that the nesting is going to take place in the positive X and Y plane, okay? And we're done with the cabinet panel layout. If anybody's got any questions about using that utility, go ahead and put them in the questions panel. Okay, so now we're going to actually do the nesting portion of the automation. So we're going to go up here into RhinoCAM 2024. We're going to select Nest, and you'll see that the nesting browser is showed here on the left. And if you haven't played with the nesting module, if you haven't used it before, it consists of various tabbed areas in this dialog that you go through from working away from the top down to the bottom, and when you're done, you'll have a completely nested sheet geometry ready for machining. So we're going to use the true shape nesting option here at the top, and we're going to go into the select sheets. As you see, we got no sheets defined, so what we're going to do is we're going to create a sheet that is going to use to nest these parts into. So we're going to just pick the Add Sheets button. And I've got some default parameters in there already. We're going to do a 5-foot by 5-foot panel sheet. So that's 60 inches by 60 inches. We're running in inches, by the way, for the units. And for the thickness, we're going to leave it set to 0 for now. And we're going to automate that as we go along. And I'll show you how to do that. And we currently have 1 count. So we're just going to add the sheet to the list. And you'll see that we've got 1 sheet listed. It's displayed in blue right here. This is not actual geometry. This is just a area that the nesting creates for you to show you where the nesting is going to take place. So let's go on down to the next tab. So the Select Parts for Nesting tab, as I mentioned, these are all the parts we're going to nest. So we're going to just select the Parts button, and we're going to window select all of our parts that we laid out, and we're going to right click. And as you can see over here, it put all of the nested parts into the Select Parts List to Nest tab into this table right here. And if you do a quick look at these, you'll see that it has a number of panels. It's got holes in the panels, couple of panels have multiple holes here and over here and here as well. So we've got all the parts listed. One thing you do want to do at this point, you need to know the actual exact thickness of your components because it has to match the thickness of the sheet. So we get this little drop-down menu at the top that says thickness filter, and it's going to tell you the thickness of your components. Now in this list, it will always have a 0, 0, and then it will have the thickness of your components. All of the components in this assembly are 0.709 thick. Okay, so we're going to just show that there, and we're going to come back up here to the sheets and make that thickness 0.709. Okay, so now we have the sheet. Just a second, I lost my mouse. There we go. So we have the sheet defined. Its thickness is 0.709 inches. We have all of our components listed on the parts tab, and we're going to be doing one count. So we're going to lay out and nest a panel for one assembly. Okay, and it's all going to fit on this one 5 foot by 5 foot sheet. Okay, so we don't need any of these other options right now. So we're going to go to the choose nesting parameters. Now this dialog is a little bit long, so you'll see we're scrolling up and down to see all of the dialog. So we're going to start at the top for nesting options. So similar to the flat panel layout, it's going to ask you the distance that you want between the components on the sheet. So I'm going to make this 3/4 of an inch. I'm going to be using a 1/2 inch diameter end mill. So the thickness between them is going to be more than a 1/2 inch so that we're not running, cutting both panels on both sides just by running one path through it. We want a little bit larger than a 1/2 inch. So I'm making it 3/4 of an inch. That's part to part. And I'm going to make this the distance from any part to the sheet 1/8 of an inch. Okay, so we get some good clean cuts around the perimeters. So those are the nesting options there. Let's scroll on down here. You got options to automatically tag your geometry. We're not going to use that. And you also have remnant control. If you don't use the whole sheet, you can use these options to automatically calculate the portion of the sheet you didn't use, and then it will automatically use that in the next nest so that you don't waste any material. But our nest will take up the entire sheet. So we're going to pick this button here for estimate number of sheets. Now we know there's going to be one sheet, I already told you, but if you don't know, just pick this button here and it'll calculate based on the number of parts that you have, the size of your sheet, and it's going to tell you how many sheets it's going to take to nest these components. So I have one sheet required, and I mentioned that if you don't know how many sheets when you define your actual sheets, you can leave the total alone, and then you can use this little utility here, estimate number of sheets. It'll calculate it for you. Pick this button, it'll automatically add those number of sheets to the Sheets tab. So it tells you that it's been updated, the number of sheets to 1. So that dialog goes away. So what did we do up to this point? We selected our nesting type. We did a true shape nesting versus a rectangular nesting. True shape just takes the actual shape of the part into consideration when it's nested, and the rectangular just takes a rectangular area around the part and nests it. And then on the Sheets tab, we created a sheet 60 inches by 60 inches. And we left the thickness alone at 0, or I guess it's at 0 when you first create it. And then we went down to the Parts tab, and we used the Select Parts button, and we select all of our panels that we laid out flat using the utility in the mill module. And you see our count is all set to 1. And you also see that the parts that have cutouts in them will show those cutouts as a part and a whole. okay? So we got 2 panels that actually have cutouts in them, okay? So then we went down and we set our nesting parameters. What do we want to use for dimensions and calculating our sheets automatically. Went back and set the sheets count automatically. So now we're at a point where we can actually execute the nest. So we pick the execute nest button. So what this is showing you, just an outline of the parts. This is not the actual nest. This is just an outline showing you where your parts are going to be nested at on the sheet. And if you had multiple sheets, you'd have each sheet listed here in the sheets list, and you can see each sheet and see how the parts are nested if multiple sheets are used. And if for any reason a part wasn't nested, some reasons for this may be that if you have a component that is not the same thickness as the rest of them, it will not be nested on this sheet that is 0.709 thickness. It will actually tell you the different thicknesses. If you have another component that's a different thickness, then you can go into the select sheets and create a second sheet with that exact thickness, okay? So, but all of our parts are on one sheet of the same thickness, okay? So now we're gonna go to the last tab here on the commit nesting tab, and we're going to create all the components in a separate layer, okay? And we're gonna go ahead and pick the commit nest button. Now, once you pick this commit nest button, the actual geometry, the actual solid panels are gonna be laid out on the XY plane. So once you do that, you're telling the utility here that I'm done, everything is how I want it, and I'm gonna commit it. So you see that went really quick. It created a layer up here, okay? Okay, if we just do that, you'll see that the nested layout is now on one layer called a rectangular sheet, and it just automatically gives it a name. Okay, so at this point, we have the nested sheet. Let's go ahead and do this. So we got the nested components, and then we got our laid out components, okay? For now, we're just gonna go, sorry about that. We're gonna go to the top view, and we're going to go ahead and hide this for now, okay? So I'll just hide that. Okay, so here is our nested sheet of components. This is the sheet, if you recall in the slide at the beginning, was used in step 3 of actually laying out your components on a sheet. So this is what we're going to use to actually do the machining portion of the webinar. Okay, so at this point, we're going to go ahead and create a knowledge base that we can use on this sheet layout here. And we're just going to go in and we're going to, let's just create another, sorry about that. Let's go ahead and create a new file for our knowledge base. And we're going to use this new file as a template for creating our knowledge bases. It doesn't have to be this knowledge base. It can be any knowledge base. You can do all of your operations in one file that you want in your different knowledge bases. And at this point that we're working here, the knowledge base at this point is not associated with this sheet. Okay, so you don't even need to look at this sheet to create the knowledge base. So we're gonna go new, and we're gonna go inches. Okay, so we've got a new, completely new part displayed, and we got a number of layers up here. Let's go ahead and delete these real quick, so you don't get confused here. Okay. Now, for the knowledge base, we're going to create the knowledge base based on layers, which means that everything in a certain layer is going to be machined with a certain operation. So if you recall the shape of our panels, we had basically an outer perimeter of all the parts, and we had some parts that had cutouts in the middle. So we've got an outer perimeter and an inner perimeter. So we're just going to create 2 layers here, and we're going to call it outer to be simple, and then we're going to create another one and call it inner. Okay, so these are the two layers that's going to be used to assign, to grab the geometry from when the knowledge base is applied. Okay, so now we're just going to go up in here and we're just going to create two operations for our knowledge base. If you recall, with the flat panels, as I mentioned, we have an inner and an outer. We're going to use a profiling operation to do the outer perimeters, okay? And then we're going to use a two-axis hole profiling operation to cut the circular holes for our components. So we're just going to create some just dummy shapes here. We're going to make one square, and we'll make one circle, okay? And as I mentioned, this geometry does not have to be associated with your sheet. It doesn't really matter at this point. We're just using this geometry to serve, to create the operations that's going to be in the knowledge base. So we're going to go up to two axis, and we're going to do profiling, and we're going to select our rectangle. And we're going to, at this point, we're going to completely program this profiling operation. We need to create a tool. So we're going to create a flat end mill, a 1/2 inch diameter. All the default parameters are fine. So we're going to save this as a new tool, and we're going to exit. Okay, so now here's our flat end mill, a 1/2 inch. Feeds and speeds, we're going to skip over. We're not going to talk about those. Clearance, we're going to give it. Now, since at this point, our knowledge base doesn't know what the thickness of the sheet is yet, so we're just going to give it a thickness that's, a clearance plane that's high enough off of the XY plane to encompass our sheet. So we're just going to say 1 inch for the clearance plane definition, and we're going to leave the cut transfer method to the clearance plane. For the cut parameters on this operation, tolerance is going to be 1/1000th. We're going to use a mixed cut direction. We'll start point, we'll use it at the midpoint of the longest side of the component. And for the cutting side, we're going to use inside, outside for closed curves. So if you recall in our panels, we had on three of the panels, we had interior cutouts. So this operation we applied to the outside and then also the inside. So we're going to use inside outside for closed curves. We're going to cut the outside, and then we're going to pick this alternate using nesting, which means it's going to also do the inner cutouts and automatically figure out the inside versus outside. So it's going to do all that for you. So we got the parameters for cut levels. At this point, we don't know what the thickness of our sheets are possibly. So you may apply this knowledge base to flat panels that are, ours is 0.709, but if you have one at 0.5 or 0.625, okay, you can use the same knowledge base to cut all of those sheets. And to do that, we're just going to set the geometry at the bottom. So our geometry is going to be on the XY plane, and it's going to be on the bottom of our sheeted components, okay? So that allows you to apply this to a number of different possibility operations. So we're going to do at bottom, the total cut depth in our part, as we're just going to put 0.709. This can be the exact thickness, or it can be a thickness that's a little bit higher. It could be 7.5. Okay, and if you want to do this to multiple sheets that are a little bit higher than 709, you can make this 0.75 or even 1 inch, whatever you want to do. That's the height that it's going to actually cut. So we're going to set it to 0.709, and we're going to hit the tab key, and it's going to apply the 709 to the rough depth, 709 to the rough depth per cut. So we're going to have one cut at the bottom, okay, and it's going to be one cut level at the bottom. If you want to have multiple levels, you can do everything that you need that you want to see on your sheets. Whenever you apply the knowledge base, you can set them here. And we're going to do the depth first for each cutout or perimeter. Entry exit, we're going to use a long path, and we're going to use lines. Let's use none for the exit, because with these panels are going to be relatively close together, so we don't want to use lines and arcs. We don't want to extend our entry exit out past the perimeter. So we're using a long path. We're going to use none, and then we're going to set an overlap here 1 inch to clean up the start point. Okay, so advanced cut parameters. We don't have any arcs on this particular panel, but you may apply this knowledge base and you may have arcs on other parts. So we're going to set the arc fitting tolerance to 2 times the global tolerance here. And everything else, if you needed to add bridges and tabs, we're not going to do that. Corner parameters. I like really sharp corners, so we can set it to go past the corner without having to roll around the corner and degrade that sharp corner. So we're going to use sharp corners, and we're going to use sharp corners on any inner cutouts. Sorting, it'll automatically sort your profiles. We're going to do it based on minimum distance. Let's generate that. Let's turn that on. So there's our first profiling operation. And we're going to create another one, which is the whole profiling. So let's go up here and move along. Let's move along a little bit faster. So we're going to go whole profiling, and we're going to use this circle, okay, for the geometry. And we're going to use the same tool. Feeds and speeds, clearance, all going to be the same. For the parameters, a tolerance of 1,000th. The location of cut geometry is going to be at the bottom. Now, this is important because this determines where the knowledge base is going to go and where your curve. We're going to set it up by selecting everything on a certain layer, and those curves on that layer are going to be on the XY plane. So you need to make sure this is set to the bottom, at bottom. And for the whole depth, we'll make that the 709, which we know is the thickness of our sheet. And everything else is fine. Entry and exit. We're going to do a long path to keep it tight in this circular perimeter. And we're going to pick none. And we'll also do an overlap here. Okay, sorting again, minimum distance. Let's generate that. Okay, so we got 2 operations. We got a profiling, which has 1 cut level. We have a whole profiling, and whole profiling, it's based on the pitch of the helical motion. So our pitch is probably, smaller, obviously, than the thickness of the part. So it made a couple of rounds of this helical path to get from the top of the sheet down to the bottom. Okay, and here is our ramp entry. Okay, at this point, these are the 2 operations we're going to use in our knowledge base. These are the 2 operations we're going to use to cut this sheet. So at this point, we can go ahead and create the knowledge base. So we're just going to select the setup. We're going to go to the knowledge bases menu. We're going to say save the knowledge base. And it's asking you where you want to put it. So I'm just going to put it here on my local machine. Okay. I'm going to put it in here. I have one already in there. I'll just override it and just give it a name that you understand, so you can identify what operations or what application that knowledge base is for. Okay, so we're just going to use KB template complete. We're going to overwrite that one and pick yes. So at this point, we use this template file. Let's go ahead and save this file as a template, or just save it. I guess we could save it as a template, but we'll just save it here, and we'll just name it KB template. Okay, file. Okay, so we save that, and you can use this same file. You can keep adding operations to this file and just add them to your knowledge base. You can use this to do all of your work on the knowledge base, or almost all of it. Okay, so we got that. Now we want to go back over to our nested sheet. And we want to go into the mill module, because we're going to be doing some machining. Let's grab that and put it up there. Okay. So now let's do a quick review. We used the flat panel layout to lay out our assembly. We nested the assembly. We created a knowledge base just in a template file, just to use as a dummy file to create your operations in the knowledge base. Now at this point, if you recall, we created 2 layers and we put some geometry on those 2 layers. So I'm going to go ahead and create those 2 layers again over here. One was inner and one was outer. Okay, so we got 2 layers, inner and outer, and let's go ahead and do this isometric view of this. Okay, so at this point, you need to have the geometry on these 2 layers because that's what's going to be picked up when you run your knowledge base. It's going to pick up the geometry on these 2 layers automatically. So we're just going to go to the bottom here. We're going to create some layers. We'll make the outer layer the active layer, and we'll just create some curves. Curve from object. We're going to go duplicate face border, and we're just going to go around and select all these flat panels. Right click. So it created these curves on the outer layer. Okay. However, at this point, I want to move the circular cutouts, okay, to my inner layer. Okay, so I'm going to set my filter, or just grab my curves here, and I'll use the Shift key to select these curves. Okay, so we got all of our inner cutouts, and we're going to copy it or change the object layer to inner. Okay, so let's just take a look here what we've got. Okay, so we got geometry, curve geometry. It's on the XY plane, and this will be at the bottom of our sheet. And we have curves on the inner layer, and then curves on the outer layer. Okay, this is important. The name of these layers is important, and it's important that you have all the geometry you're going to use for a particular operation in your knowledge base on the proper layer, because we're going to define our selection rules for the knowledge base, and it's going to be based on layers. So it's going to grab everything on a certain layer. So you just need to know, when you do your layering standards, make sure you understand what the layer names are and that they're the same, okay, in the knowledge base and in your template file, or in any file that you're going to apply the knowledge base to. Okay, at this point, we want to assign some selection rules to that knowledge base we just created, as I mentioned, so that it automatically selects the geometry for us. So we're just going to load the knowledge base, and you can load the knowledge base automatically up here and run it, or you can load it from down here to set the selection rules. You do need to do it from down here if you're going to set your rules. So we're going to do K-Bases tab, and we're going to select our knowledge base that we created. Let's go ahead and find that. Okay, so here's the knowledge base that we just created. So we're going to select it, and it loads it down here. So you see that we have the two operations that we created in our template file. One's a profiling operation, one's a whole profiling operation. All of the parameters that we used in the operation are all defined in this knowledge base right here. Now at this point, we want to assign some selection rules. So we're going to expand these 2 operations. You see this icon for selection rules, and it's starred. That means that no selection rules have been set yet. So we're just going to double click on that icon. We're going to look at this dialog, geometry selection rules. Okay, this applies to this operation and this knowledge base. So we're going to apply it by layer. And for the profiling, we're going to use the outer layer. Okay, this is the outer layer here. I'm going to pick OK. And we're going to go to the whole profiling selection rules. And we're going to go by layer. And we're going to pick the inner layer for our whole profiling. Again, the names of these layers have to match the layers that you have created and the layers that you have created in your knowledge base as well, so that everything lines up. Okay, so we got the inner, we're going to pick OK. So we see that the stars have went away. So let's go ahead and save our knowledge base back out. Okay, so we got that saved. Now at this point, we flattened our panels out on the assembly.
I think you just loaded it again, Don. You haven't saved it, I don't think. Go back and look at the knowledge base selection rules.
Oh, okay. Oh, yeah, you're right.
Yeah.
Sorry about that. Okay, so that goes on the outer. I saved the knowledge base, not sure why it didn't save it. And this will be by layer, and this will be inner. Okay. And we're gonna, we're gonna save it. Pick the wrong icon there is what it was.
Yeah.
So go here, we're gonna go to marketing, webinars, 24, May, final, and we're gonna save it as this template. Thank you, Joe. Okay. So we got our knowledge base created, we got it saved. Let's hop over to our actual panel layout. Okay, it looks like we got to load that. I don't see it here. Okay, so let's go ahead and go back over here. And okay, start on assembly.
Oh, that's the file, Don. That's exactly the file. The one that's open is what you have. You have turned everything off.
Oh, I'm sorry. I'm sorry. Sorry about that. Okay. Okay. So we're going to turn off our components. Let's turn off layer 1. Okay. So now we have the sheet. So these are the components that we're going to assign the knowledge base to. Let's go back over to our tools tab. At this point, we had the knowledge base loaded here, but you can do this on any file. You can apply the knowledge base to any file that you need to. It doesn't have to be created in the same file that you're going to machine. For us in this webinar, we just have it in the same file. So we're going to load our knowledge base. Okay, here is the knowledge base that we just created. So we got our operations up here. At this point, everything is set up to machine this or create the operations automatically. We just have to regenerate them. Okay, not sure why it didn't grab that. Okay, let's check this again down here. Okay, profiling.
I think you got the outer one hidden. Maybe that's why.
Oh yeah, that's why. You're right. Okay, let's regenerate those again. No, that wasn't it.
Yeah, you got to reload the knowledge base.
Okay, okay, let's cancel that. Okay, let's get rid of that. Load that. Okay. There we go. So we just loaded our knowledge base that we created. The geometry is automatically selected based on what the layers were named. So it grabbed it automatically. And just as a quick recap here, again, you can create your knowledge base separate from this file. And you just, in your mind, when you set up your knowledge base, you got an idea, obviously, of what the type of parts are you going to be cutting. You can do all of that separate from the actual file, the sheet file that you're going to cut. And then you can bring that knowledge base in to whichever sheet that you want to apply the knowledge base to and just regenerate your operations. So at this point, you do the knowledge base and then you can apply it however many times on however many sheets that you want to apply it to. Now, obviously we talked about these 3 stages, and it's a little bit of work to set this up. But once you have it set up and once you have your knowledge bases verified that they work the way you intend them to work, from that moment forward, everything is going to be automated for you. The layout, the nesting is going to be automated. Throwing in the knowledge base and regenerating it, that's going to automate the machining, creating the actual operations. And we can just simulate this real quick. Let's create a stock. So there's our outer cutouts for the perimeters, and there's our inner hole profiles. Okay. Now, at this point, I'm basically done with my portion, and I'm going to pass it over to Joe, and he's going to talk about how you can make your life even easier so you won't have to do everything that I just did in the webinar. So he's going to talk about scripting. Joe, you want to go ahead and take it? Joe?
Yeah, go ahead. Yeah.
Okay. So I'm just gonna transfer the screen. I'm gonna make Joe the presenter. Okay, so big yes. Okay, at this point, Joe, you should have it.
There we go. I hope everybody can see my screen.
Yes, I can see it.
Okay. All right. So what Don had showed, there was a lot of manual processes that he had gone through. And the way we see it is there's 3 major pieces that he went through. One was actual layout, the panel layout, which was a manual process, even though most of it was automated in that dialogue. And then the second process was the actual nesting. And then the last one was the knowledge base creation. And then, of course, he had other manual processes that he was showing, which is basically the creation of the curves. He had to go in and select all the machining geometry in the actual file that was going to be machined, and then actually loading the knowledge base and then machining it. So in terms of automation, what we can do, the state of the art right now is using either Python automation, using Python scripts, which is what I'll be showing today, or you could write your own C++ or C# using .NET, which is a little bit more complicated. So for this webinar, we'll be just showing you pieces of these processes that can be automated. So what we have here is, the actual part that was nested. I've loaded that part. And I'm going to run, one of the things that we can automate is using Rhino scripting language, the actual creation of the machining geometry. So I'm just going to run a script that I've already created. Go to Tools in Rhino, and then go to Script and say Run. Then I'm going to select the script. So I can create flat borders and layers. Let me do that. So this automatically created 2 layers, outer and inner, just like Don had created, using a manual process. And as you can see, this one, let me turn that off. Let me make this turn that off. That's the inner layer. Make that the active one, turn that off. And that's the outer layer. And then also, additionally, I was able to create them in different colors, based on the layer color, of course. So this is one level of automation that you can do. Write a script to go through the nested panels and create these. So I will show you, this is using purely Rhino's scripting, technology, as well as Rhino's scripting API.
Can you show us the scripts also, Joe? Would that be possible?
Yeah, I can show. Yeah, I can show you the scripts. So I have the script editor on the left-hand side here. I'm just going to show the script that I ran, which would be flat borders and layers. So this is the script. So for those of you who know scripting, let me go through this very quickly. So basically, this section of code goes through this set of poly surfaces in the model. and then creates a list of them. And then once you get that list, it also creates two layers. One is called inner and one is called outer, and then applies the colors to each of the layers. The outer one is called blue layer, as you can see, the outer one here, and the inner one is green. So if I turn the inner one on, turn that off, that's inner one is green. And then what it then does is it cycles through each of the B-reps, which is basically the poly surface. They're called B-reps internally. And it goes through and it duplicates these edge curves for each of those faces, and only outputs the ones that have that are on the XY plane with Z equals 0. So that's what this does. All this is going through each of the poly surfaces and selecting each face and gets the edges out and then extracts them and then joins them all and then creates the curves. That's all it does. If you have any questions, yeah, go ahead and put it in the questions window. And if you are able to answer, we'll do it, or we can send you an email because it can get quite complicated, some of these things. And we can share these scripts with you as well when we're done. I'll also show another script here, the very similar script. Instead of creating layers, you can also create, by curves. I'm sorry, by color rather. So you can assign different attributes. So here's one with colors. Create flat borders. So this one, what it does is it uses colors. So, and the nice thing is in our knowledge bases, we can also select curves for machining using colors, as Don showed. You can either use layers and or colors. So that's why I've written this one that basically will output curves using colors. Okay, let me reload this, or let me do actually, let me reload the file. So there's no layers except for the layers that were created by the flat panel and the nesting. And so now what I'm going to do is I'm going to actually show you how the second piece of the automation puzzle, which is actually loading the knowledge bases that Don had already created and actually doing the machining. So I'm going to run script again, go to tools, script, run. And then I'm going to say create flat borders and machine by layer. So this one automatically did it. Oh, no machining creatures was done. Okay. Something's wrong with the script. Sorry about that. Let me reload the file. Okay. I'll show you the other one. Let's see if that works. Interesting. Okay, so this is okay. We can look at we can debug this live. We have some time, so I can debug this pretty quickly. So let's load that file up. Let's load that script up. I'm going to delete this. I'm going to load that script.
Actually, Joe, this is what the users will do. We'll have to a number of iterations to get it the way they want it.
Right. Yeah. So this one, let's look at the script here. That's what it's supposed to do. So basically, it piggybacks on the other script that I just showed you. It just creates these layers, outer and inner, and then it creates these curves and then outputs those curves, and then it loads, and then it loads the knowledge base that Don had already created using layer, and then it does a regenerate all. So this is all the CAM API. This is our API, MecSoft's API. So we're actually loading a knowledge base here, and then we're regenerating all the operations. That's what it's supposed to do anyway. So, okay, let's see what's happening here. So I think the problem could be in the knowledge base selection. So because we know we selected the curves correctly or created the curves correctly. So I'm just going to load the knowledge base, and let's go to webinars. So let's KB template using layer knowledge base. So I'm going to go selection rules, layer filters. Okay, that's the problem because it didn't have any layers selected. So I'm going to create a layer. So what I'm going to do is I'm just going to run my other script to create these layers. Tools, script, run. I'm going to run create flat borders. So this one created the outer and created the inner. So now I can go set up my selection rules. I go to layer filters, okay, outer, and then selection filter rules, go to layer filters and inner. Okay, so now I'm going to save my knowledge base. Again, go back to the webinar folder. Using layer VKB, I'm saving it. Okay, let me reload the file. Let's see if this works this time. Okay, so now I'm going to go back and just like Don did, load the knowledge base. Come on. Using layer. Okay, it looks like everything's okay. So I'm going to run my script now. So let's go ahead and run the script. I can run it either in the script window here by clicking on that, run or play button, or I can go to tools and run it there as well. So let's run it here. There you go. Did it. It loaded the knowledge base, outer and inner. You can see the screens. And the control geometry was selected properly. And the whole profiling also, the control geometry should have been selected. So let me turn off this. It's been selected. There you go. Now the curves. Let me turn that off. There's the outer profiling being machined using the profiling operation. Let me turn this off. So, and then you have the inner profile, inner hole profiling for all the holes that were being machined. So this is the second level of automation that we have. So the creation of the machining geometry was automated, and then actually loading the KB that you've already predefined and machining that automatically was also automated. And then there's other things in the API that you can do. You can post-process this automatically if you wanted, and things of that nature. So there's additional layers of automation that you can add to it. That's pretty much where we are in terms of the automation. Some of the things we're looking at in future releases are actually automating the other three pieces that I mentioned, the three other. I mean, the knowledge-based automation is really not possible because we are setting up based on user intelligence. On your shop floor, what you've learned, what's based on your experience, that's what you're going to be setting up in the knowledge base. So that's very, very highly difficult to automate. But the layout and nesting, we will be able to automate that using, again, knowledge bases for layout knowledge bases and nesting knowledge bases. So once you set something up using, again, your experience and the knowledge base defined in your shop, you'll be able to load it in the API and then run these. So those are some of the things in the future that we're looking at. That's pretty much.
We got some questions coming in.
Okay.
One of them goes back to the actual nesting portion. The question was,
Okay.
could you have nested grouped curves, or does it have to be polysurfaces? No, you can nest grouped curves. There are a little bit of caveats. Joe, you want to mention them for nesting curves?
Yeah, I mean, in the nesting module, you can select surfaces and or curves. You can't mix them both. And then we also have an option to nest these. So if you had outside and inside that you wanted to maintain, we have a parameter in nesting that will allow you to keep that topological relationship intact in the nesting.
Mm-hmm. So that when you commit the nest, you will actually be creating your 2D curves for each component, similar to what you see here on the screen. It won't be a solid; it'll be a curves. Okay, we got another question. They entered late into the webinar, and they was wanting to know, saying that they can't see the selection rules; they can only see the control geometry. So I'm going to guess what might be going on here.
Yeah, I think the selection rules are in knowledge bases.
Yeah.
So let me do this. So if I load a knowledge base, it's only available in knowledge bases. It's not in the operations. If you're looking at the operations, these are not. This is not where you'll find it. You'll see it in the knowledge base tab. You'll see the selection rules as you load the knowledge base.
And can we show the colors too, Joe, in the selection rules?
Yeah. Yeah. So you can the knowledge base rules you can select by curve types, or you can say you can use layer filters, or you can use color filters.
Okay.
And you
Any
can
other
actually
questions? You guys put them
color.
in the questions panel. We'll address them right now. We got a couple of minutes left. Okay. Well, it looks like that's about it, Joe.
All right. Yeah, if you have any other additional questions, please feel free to drop us an email at support@MecSoft, and we'll be happy to answer. And then, like I said, we will clean this up, the video, and then send it out to you guys
Okay.
once it's ready. Thank you very much.
Okay.
And then we'll see you next month.
Thank you, guys. Take care.